Okay, so here I have, I'm here in this week's Substack. I'm going to be covering a paper, new paper in the diff and diff literature on continuous treatments, and which is a popular, high in demand question by a lot of applied people. And there's now a new paper kind of at the front of the pack of a non-pack by Brant Callaway at the University of Georgia, Andrew Goodman Bacon at the Fed, and Pedro Santana on leave from Vanderbilt at Microsoft. And today I have the pleasure of getting to interview Brant Callaway, one of the authors. So Brant, thanks for letting me talk to you.
Yeah, thanks for having me.
Well, so I want to just start out, and a lot of people don't really know what economics even is, let alone what econometrics is. They don't, or rather, they don't know what econometricians do. And so I was kind of wondering if we could just start up and just say, what is it that drew you to econometrics, and what is it that kind of keeps you in it?
Oh, that's that's a hard question, I guess. I mean, I didn't know, like when I was in graduate school, I didn't know that I was going to do econometrics. I thought maybe at the start that would be a possibility. Although I was at Vanderbilt for graduate school, and I was kind of second year, I was working both with the econometrics group, but also with kind of the labor. And Vanderbilt has a big economic history group, and so I was working with those guys too. And I don't know. I mean, I kind of I don't know. At some level, I just chose. I mean, I still like labor stuff. I like economic history stuff. I think if one day if I can't keep up with what's going on in the econometrics world, I think there's a lot of stuff that I would like to learn about and work on, especially related to kind of economic history stuff. I'm at the University of Georgia. I grew up in Georgia. I like kind of historical, rural sort of things are interesting to me. So I don't know. I mean, I didn't have like some big path or like initial sort of being drawn to econometrics besides just liking it when I was in graduate school. Maybe the second part of that answer, Scott, is that in a lot of ways I find econometrics to be easier than applied work. So in econometrics we can assume everything else away except for maybe like the one thing that we want to study.
Right.
And I have a few papers where I kind of dream of like writing papers at the intersection of labor and econometrics. But then you start to do that, and you realize there are a lot of things that it's not just deal with one issue at a time. It's applied work has to deal with a lot of issues all at the same time. So maybe maybe it's just easier and I'm better at holding.
Well, what do you think makes you good at it? What is it in your personality and your skill set that you find that really helps you be good at econometrics? Because a lot of us love applied work or in economic history, and we wouldn't in a million years think that we'd be good at econometrics. So what is it? What's that background that you have that makes you good at it?
I think a lot of people would be good at econometrics if they. I mean, I think there's a technical bar. So I mean, like if you want to publish a paper in Journal of Econometrics, the technical stuff has to be up to par there, and I think you have to figure out a way to get over that bar. And I mean, I think some people in econometrics are kind of, I don't know if competing is the right word, but their contributions are in a technical sense. But I think there are a lot of people in econometrics who are doing things that I think are directly coming from thinking about economic questions. And I think if that's your style of econometrics research, I think that I think there's a technical hurdle that you have to get past. But I think plenty of economists can do that. I think that that's just something you have to do.
Yeah. Well, so what is it that drew you to diff and diff? How come diff and diff has become so preoccupying your creativity and your energy?
I mean, so I think a lot of people associate me with diff and diff in particular. I like to think that I'm more interested in kind of like causal inference sort of questions with panel data.
Yeah.
I mean, I just think that we have a lot of access to panel data sorts of problems, and that just sort of even like the very simple idea. I mean, way back, like I sort of have the idea that, like, if you're in a world where you see outcomes for people or firms or whatever before some policy is implemented, and then you see a world after outcomes after the policy is implemented or a treatment happens or something, that sort of seems fundamentally useful for learning about effects of policies. And then how can you exploit that sort of information to answer sort of questions that are interesting to economists is I think that's the sort of thing that I think about all the time. I like diff and diff in particular because, I mean, this is sort of an opinion, but like, I think you can do a lot of like cool stuff when you have, or like think about very complicated and interesting models in cases where you have a large number of time periods. But my sense is that, like, more often than not, economists aren't in that world, or either that you're not willing, either you don't have that much data, or else that you're not willing to believe that, like, the structure, that, like, you can learn about the structure from like the distant past in order to exploit that kind of data. So I mean, I think diff and diff sort of like comes up as like the natural, at least starting point to think about causal effects in a world where you have panel data, but not that much panel data.
Right.
You have sort of micro sorts of panel data.
Yeah.
And so I mean, that's, I think, one of the reasons why I've done a lot of work on that. But
yeah. Well, so I want to, I'm going to ask a question now, and then I'm going to kind of like revisit it at the end. But I wonder if you would just tell us in your words, what is, in your mind, difference in differences? What makes it different from, say, you know, a panel literature? What exactly is it?
Yeah. I didn't know what you were driving at first there. Yeah, that's a really good question, I think, and I think sort of confusing. I'm not sure that there's like a something that's necessarily 100% agreed upon, but I'll tell you what I think is. I think that difference in differences is about, one thing is about that, like, you have a time period where no one is treated yet, so that, like, you can see that, saying like the textbook version of this, so there are two periods, and then the first period, either no one is treated yet, or we just drop everybody who's treated. And so you see some people become treated, and you see other people not become treated. That's not really a feature of like if you're just looking at like textbook versions of I don't know, within estimators or something.
Yeah.
I don't think you'd see that sort of requirement. I think that's the reason why, as far as I can tell, I think that's the reason why you put difference in differences typically in the natural experiment category.
Right.
You'd have a different section of a lot of textbooks about panel data.
Yeah.
Estimators.
Yeah.
And then I think the other thing is about parallel trends. If paths of untreated potential outcomes, if they would evolve in the same way for the treated group as the untreated group.
Right.
I mean, that's going to be like, I think, the dividing line between, I think of difference in differences as being a quite simple way to do causal inference. But I think that's going to be a dividing line, say, between like, I have another paper about like interactive fixed effects models, and sort of that like parallel trends that I see as being like a fundamental difference between calling something difference in differences versus calling something a different approach to think about causal effects.
Got it.
With panel data.
Got it. Okay. So you got this new continuous treatment paper, and, you know, sometimes, like, you know, if you did bad in a class in college or high school, you'll come home to your parents and you'll say, I have good news and I have bad news. And you'll kind of go, you know, first you kind of want to like, maybe you tell them the good news first, right? So I was wondering if you could just tell us a little bit about this paper, and tell us in terms of like what you consider to be the thing that's going to make people kind of light up and be sort of encouraged.
Yeah, I think I'm going to be like in the bad situation for a college student, that I got a lot more bad news than
Yeah, right.
good news here. Yeah, well, okay. So like, I think if you think about like what's been happening in the difference in differences literature, like you think about Andrew Goodman Bacon's paper, you think about other papers that are talking about like so like if you take a step back, like the way that people have implemented difference in differences for a long time has been with two-way fixed effects regressions,
Yeah.
and then there are these papers in the last couple of years saying this probably isn't such a good idea. For a number of reasons. And I think you've had plenty of people talk about that sort of stuff.
Yeah.
But then almost immediately after that, you have a number of other papers coming along and proposing fixes to that. And basically the issue there is that like sometimes already treated units serve as a comparison group for units that become treated.
Right.
And in a world where, especially if you have treatment effect dynamics, you can get very poor estimates using two-way fixed effects regressions.
Right.
But then there are like other papers where essentially the idea is just don't make those comparisons, like explicitly make the good comparisons and explicitly don't make the bad comparisons.
Yeah.
And all of that works. And I think that in some sense, that's probably a main reason for a lot of the popularity of this stuff, is that like there was something that everybody was doing. There's sort of this problem that once somebody tells you what it is, it's sort of obvious why it's there. And then there are these other solutions that are not really very complicated, and that it's not like you have to, I don't know, run some computer program that takes hours or something. You just click a different button and it sort of fixes everything for you. In the continuous treatment case, like all those same issues still crop up. Like, I mean, when you move to a more complicated treatment regime, you wouldn't expect things to get better. If anything, you'd expect things to potentially get worse.
Yeah.
And two-way fixed effects regressions can still go quite poorly for the same sorts of reasons. That already treated units, they serve as a comparison group. You have, I didn't say this before, but you have these like, if you think about like what's coming out of two-way fixed effects regression, it's like weighted averages of underlying treatment effect parameters.
Yeah.
And the weights can be kind of weird.
Yeah.
You get the same sort of issues there. Those sorts of things you can fix, just like the literature has done previously. But I think they're more like fundamental issues that crop up when you move to the case where treatment can take more than one value. It doesn't necessarily even have to be continuous. Just as soon as it can take more than one value, things are going to be more complicated, I think.
Yeah. So the thing that the positive news might be that some of this some of this, like the things that we already knew about two-way fixed effects with the binary treatments, it's not a huge leap in terms of the continuous treatment to sort of start diagnosing the problems. Is that kind of where you're saying?
I guess so. I'm not sure that that's a huge positive, but
well, so what's the bad news?
Let me, Scott. I thought of one more small positive.
Okay.
If you have a multi-valued treatment, you can do difference in differences without having to have access to a group that remains untreated.
Right.
So like you can compare paths of outcomes for, say, a high dose group to a low dose group, and like the part that would depend on having an untreated group, it cancels from both of them, and so you don't need it. So
right.
So that's a positive.
Yeah, sure, because that's like might be a more typical case, like raising taxes or raising a minimum wage or something like that. Right. Yeah. So in some ways it's like the thing that we're not having to worry about that our entire question may not be feasible. It's like that's not the part of the bad neuse. So
I think that's right. Yeah.
What's the bad news? Okay.
So the bad news is that like inasmuch as like say you have treatment effects. Now you have treatment effects that maybe are a function of the dose or a function of the amount of the treatment that you get. The bad news is that if you want to compare these to each other, so you want to compare the high dose treatment effect for high dose relative to treatment effect to the low dose,
Yeah.
you want to call those differences causal effects.
Yeah.
I think standard parallel trend sorts of assumptions aren't strong enough to rationalize that sort of comparison as being a causal effect.
Mm-hmm.
And that so that also translates to, so in as much as like say beta from a two-way fixed effects regression,
Mm-hmm.
I think most applied papers would interpret this as basically some kind of average causal response, sort of like a derivative of the causal effect.
Yeah.
Because a derivative amounts to like making local comparisons across different amounts of dose.
Yeah.
Those sorts of comparisons are problematic or at least hard to rationalize under a standard version of parallel trends, where what I mean by that is that parallel trends means that paths of untreated potential outcomes are the same maybe for everyone or across different values of the dose or something.
Okay. Yeah, it seems like this issue of heterogeneity is creeping up again in this paper, but it's got a different form than before, because it's not really the problem in this paper isn't so much dynamics, it's heterogeneity with respect to the treatment effects across these units that receive different doses at that dose, right? Can you tell us a little bit more about that? What's going on here?
Yeah, so I mean, if you think about like okay, so what difference in differences does, even in the case where you have a binary treatment, it identifies almost all papers have this, that they target identifying the ATT, the average treatment effect on the treated.
Yeah.
And that's average treatment effect on the treated is a local parameter. It's an average treatment effect parameter corresponding to the treated group.
Yeah.
You have a continuous or even just a multi-value treatment, standard versions of parallel trends, a standard sort of difference in differences setup. What it would be useful for identifying would be ATTs that are local to that amount of the dose.
Yeah.
So you get treatment effects that are local to, say, high dose or low dose.
Right.
But what it doesn't deliver is like justifying comparisons between ATTs at the high dose and ATTs at the low dose and calling those differences causal effects. Because all you're recovering a bunch of local average treatment effect sorts of parameters.
Mm-hmm. Mm-hmm. Yeah. So
it's sort of like if you're used to maybe like the IV literature, I think we're used to the idea of, say, if you're studying some particular treatment, if you have one instrument and I have a different instrument, we may get different local average treatment effect parameters that may be hard to compare to each other.
Right.
Different just on the basis of our instruments.
Right.
And this, I think, sort of has the same flavor, that like if you're identifying very local treatment effect parameters, it makes it, you need something else in order to justify comparing them to each other.
So what's the bias? When I run a diff and diff with a continuous treatment, I'm going to get some treatment. I'm going to get some, you call it the ACRT, right? Yeah. And that so you get, so you could tell us what that means. Is like you've got this continuous treatment and you're going to identify this new causal parameter that, is very intuitive, but we haven't heard it before. And then you've got this bias term. And I was wondering, can you tell us, what is that treatment parameter? Why is parallel trends not deleting that additional bias? What the heck is it? What is this additional bias?
Yeah. So this ACRT thing that you said, it's just like, if you think about, so say you have, I don't know, I just keep saying low dose or high dose, but say you have a low dose. ACRT is just like, how much would outcomes increase on average under a marginal increase in the dose for that group that actually experienced the low dose. So it's basically like, if you think about this like a function, you're holding the group defined by the dose constant, but thinking about a small change.
So I go from having 10 Advil to 11.
Yeah, exactly.
Right. And so you're wanting to know, like, that's what the ACRT is. It's just the change in the ATT. Is that right?
Well,
change in the ATT?
This is the important part, Scott. It's so like the change in the ATT. So like, I like this example about Advil. So like you have some people that take 10 Advil. You have some people that take 11 Advil.
Yeah.
And the ATT, we get a causal effect of 10 Advil relative to no Advil, and
Right.
the causal effect of 11 Advil relative to no Advil.
Right.
And so like the ACRT would be like if you hold fixed the group that took 10 Advil
Yeah.
and thought about how much their outcome, I don't know, their headache or whatever would change
Right.
if they had taken 11 Advil instead.
Yeah.
But the difference in ATTs is the difference between the treatment effect for 10 Advil relative to the treatment effect for 11 Advil. And the story that standard parallel trends doesn't eliminate is that the group that takes 10 Advil could be systematically different from the group that takes 11 Advil.
Yeah. So it's a kind of like selection bias is what it sounds like.
It's a kind of selection bias. Yeah.
Right.
Yeah.
Right.
There could be bigger effects of Advil for people who took 10 relative to 11 at any value of the number of Advil. I probably said that probably people take more Advil. I probably said that
they have worse headaches.
Yeah. So what I just said, I think would be the exact opposite of what you worry about.
So let's say that we are living in a world where, some units take 10 Advil and some units take 11 Advil, and they're doing it because of, quote, selection on gains, right? Yeah. Like, so what is that going to mean in the diff and diff? If I believe that people are choosing different levels of the multi-value treatment because of expected gains, am I already in a world where I may be in a lot of trouble?
I think yes. So I think you could imagine my examples about Advil may kind of break down here. I'm going to try it. I'm feeling like I should try it, but I'm not sure that this will work perfectly. Okay. But let's say, you could imagine like if you take 10 Advil because that's how many Advil you need to take in order to get rid of your headache, and the next person takes 11 because that's how many is going to get rid of their headache, then there's going to be no difference. Like say that decreases your headache to 0 for everybody.
Yeah.
Then if you compare ATTs, this is going to look totally flat.
Okay.
There's going to be no effect of more Advil on headaches.
Okay.
But that would be a selection, like you're saying, a selection on gain sort of story where you can imagine different things would happen if you were able to hold the whole group's constant, switch their amount of the dose. So maybe the easier way to think about this would be the group that took 11 Advil, maybe their headache wouldn't have gone to 0 if they'd only taken 10 Advil.
Yeah. Right.
Even though the differences in the ATTs could be equal to 0.
Yeah. So what have we been assuming when we've been doing these continuous treatment? In order for us to get unbiased estimates of the ACRT, what have we been unknowingly assuming in order for that?
I think something that looks like, so in our paper, we say this is slightly weaker than assuming something like treatment effect homogeneity across different doses.
Yeah.
It certainly has that sort of flavor of if you want to get a point estimate here, I think you need something that effectively, at least on average, rules out selection into an amount of the dose.
Yeah.
And there might be cases where this is plausible. There might be other cases where it's not. Probably Advil is a case where it's not very plausible, I would guess.
What about minimum wages?
It's hard to say. I think you could so I use the example of minimum wage a lot, but I'm not really a minimum wage expert.
But
since if you were motivated, you could.
States are choosing it. This is where I'm getting at. It seems like your paper is almost forcing us back to these fundamental issues about individual units are choosing their treatments for some reason. They're not flipping coins, right?
Yeah.
Because if they were flipping coins, then the ATTs would be identical across all the different dosage groups, right? So for the units that took, J-1 dosage and the units that took J dosage, they'd have the same ACR, right? They'd have the same average causal response function. And so
you're flipping a coin to decide the amount of the dose.
Yeah, exactly. Yeah. Right. Yeah. So you'd have these two groups, but they've got the same average causal response function. And so it seems like your paper is almost bringing us back to this fundamental problem of observational data, which is like these states that adopt a minimum wage earlier than these other states, like it may not be sufficient to use parallel trends with a continuous treatment variable. Am I wrong?
Yeah. I think this is right. So like, I mean, I think one of the like appealing features about differences with a binary treatment, you can't allow for like arbitrary selection into the treatment, but you can allow for a lot of selection into the treatment. And I think the sort of like main reason for that is that you're getting treatment effects that are local to the treated group.
Right.
Like if you want to extrapolate to what the effect of the treatment would be if you expanded the treatment to the untreated group, that would require bringing in a lot of extra sort of assumptions that would likely look like sort of structural or treatment effect homogeneity sort of assumptions in order to do that. But if you want to evaluate what the effect of that policy was among those that participated, then you can do it under pretty general forms of selection into the
Why? Because we're just focused on parallel trends.
Yeah. So like, I mean, if you're writing all this stuff down, so like, if you have a binary treatment, you'll notice you don't put any restrictions on how treated potential outcomes are generated, which is a really nice feature.
Right.
Another thing is that you can allow, if you start to write down a model for untreated potential outcomes that has like a time fixed effect and an individual fixed effect, like time varying unobservables, you can allow for selection into the treatment on the basis of the individual fixed effect, the model for untreated potential outcomes. And you have to rule out that people are selecting into the treatment on the basis of like the idiosyncratic unobservables.
Right.
So like states can't be like anticipating a positive or negative shock to their employment if they didn't implement the minimum wage. That's what that's the sort of thing that you have to be worried about and rule out there. But once you think about like taking states and comparing like high minimum wage changes to low minimum wage changes, I mean, maybe it's even obvious that like to make those comparisons requires believing more or less that effects for states that had a high minimum wage change, that you can recover something about what they would have been like under a low minimum wage change from the states that actually had a low minimum wage. Lower minimum wage increase. I'm not saying it very clearly, but
because it just seems like this Roy, like I've always felt like the Roy model kind of like is the most common sense view of micro, which is like, people are making decisions based on expected gains. And now I'm reading this continuous treatment paper and I see this ACRT, I see this like expression, and it's like, comparing high and low dosage to identify the ACRT. And you've got like ACRT treatment effect, which is the treatment effect at some local point on a particular unit's quote average causal response function, which is just like really nice classic idea in econometrics going back to Angerson Embens, and it's just like so neat that you guys
it's sort of like a natural target parameter.
It seems like really natural.
You'd be hoping that like you're recovering like a weighted average of
that's right. You would just hope like you're getting that, so you get this like average causal response treatment effect, which is like this little derivative along that curve, plus differences in ATTs for two different groups that chose different levels. And it's like you're just praying that these guys don't have different treatment effects at that dose, even though they didn't choose the same dose. Right. And it's almost like it's stretching. Is it stretching the credibility? If like you have, you have this kind of sorting into different levels of continuous treatments. I mean, what do I have to believe is going on to believe they didn't stop at the same level of treatment? Like, don't I have to believe that their treatment effects at those different levels of dosage aren't the same? I mean,
Say the
theoretically.
last sentence again, Scott.
Well, it's like, you chose to finish the PhD program, and I chose to drop out, right? Like, so you chose a little bit more. It seems like the fact that you went further means that my return at 4 years and your return at 4 years are probably different.
Yeah.
But why? Because you didn't do it.
Yeah.
Right. And so so it's like something's different between these two guys. Some kind of unobserved covariate is different between these two guys, and that's not getting deleted in this diff and diff. And you're just confronted with the fact that, like, you're confronted with like a very fundamental rational choice microeconomic, like, sorting into levels of treatment based on different heterogeneous returns. It just seems like we're it seems like we're in big trouble.
Yeah. I mean, so my sense, like, a super high level comment here is just like, I think that there's like kind of always this sort of tension between, like, maybe I'm saying this, I may be like moving beyond my pay grade here, but like, I mean, if you think about like a lot of like our identification strategies, I think like it's probably fair to think of these as like clever ways to think about, to ultimately like get very credible estimates of very local effects.
Yeah.
And I think that like what we're saying here is like you can get perhaps very credible estimates of very local effects if you have this, like you can get ATTs of a particular dose.
Mm-hmm.
But then when you move to a world where you want to ask more complicated questions, like, and in particular, what that means in our setup is compare ATTs at different doses.
Yeah.
That the weak or assumptions that people have often thought have been quite credible, that because they deliver very local causal effect parameters, that they're just not strong enough to recover the sorts of parameters that are often probably the ones that are most interesting in a lot of these applications. Maybe not always, but in a lot of applications, I think are perhaps the most interesting ones.
Right.
And so then, I mean, these sorts of things like ruling out those selection bias sort of terms, to me, they look a lot like structural sort of assumptions that allow you to extrapolate.
Yeah. Well, I'm just wondering, like, elasticities seem almost like they have flavors of average causal response functions, because, you're looking at the effect of, a slight change in price on quantity demanded. And that's like, the demand curve is a sequence of pairs of potential outcomes and treatments. And so, like, I'm just thinking to myself, how are we going to identify these elasticities? Am I over worried? How worried do you practically think a person trying to like estimate some elasticity of, consumption of soda with respect to soda taxes is? Like, are they, when they're running a diff and diff and they've got like soda taxes on the right-hand side and they've got like, consumption of soda. I mean, are we like, are we tackling these questions like in the completely wrong way?
I don't know that one, Scott. I mean, I think, I think at a minimum there should be things that you should think about. And I mean, I think the sorts of issues that we're talking about, like, is it warranted to make? I think the right word to use is extrapolations, but make extrapolations from like one dose to another dose, or are those justified? I think that's the sort of question that people thinking about that ought to have in mind.
Well, how do they know? What do you think these researchers should be doing when they're trying to reason that out?
I mean, I think we're kind of probably like in the beginning phases of that sort of stuff. I think a lot of people I think the first order thought should be a lot along the lines that you've been talking about. That like, is there selection into different amounts of the treatment? And I think at least in the applications that we've kind of been going through, Advil, years of education, uh, my sense is that in a lot there would be reasons to be concerned about this.
Right.
I do think so. I mean, I'm going to be rusty. I haven't been thinking about this lately, but I think they're kind of. I kind of grew up in graduate school on like partial identification stuff, and I think they're like perhaps like interesting sorts of like assumptions that you could make about these kind of selection bias terms. Like there might be a lot of applications where you might be willing to think that the selection bias was always
right.
increasing in the dose or decreasing in the dose, and so you might kind of these exercises about like saying under some conditions I get a lower bound or an upper bound on kind of like an average causal response sort of parameter. I think those seem kind of promising. We don't have those in the paper, but I mean,
sure.
It's been a while since I thought about
great. That's great. So like rather than impose these strong assumptions, just start, like relaxing them and then thinking in terms of like, what would they have to be in order for these effects? Because part of me keeps thinking, okay, for something like schooling, I could see it, this is a big deal. But choosing a I actually don't know what the minimum wage is anymore. Like choosing a $15.50 minimum wage versus a $14.75, like maybe, maybe that really isn't as Roy driven as like you think, right? Like, I mean,
I totally agree with that.
It's kind of like, I mean, even if it is, I just think like, who knows what's going in the head of these, like, these legislators when they're picking these numbers,
Yeah. And Scott, another point along those lines is like, besides like partial identification sort of ideas, you can do like local versions of ruling out selection bias. So like you might be willing to say that like one state that increased their minimum wage to $14.60 didn't select into that relative to $15.50, but that's different. You wouldn't be willing to make the same assumption for a state that increased their minimum wage to $8.75 an hour or something.
Yeah.
And so that would kind of give you like a bunch of like local kind of causal responses that you'd be willing to call causal. Whereas like you might be less willing to believe these big, like when there's a big gap in the dose, that those are causal effects. I think that's an interesting. Yeah.
So let's say that you're a referee and you get this continuous treatment paper and you're like hopeful, you're like feeling particularly good natured and altruistic, and you want to give an R&R to these people. What is it that you're kind of like at minimum wanting them to sort of wrestle with and sort of be thinking about?
Yeah. So, I mean, I think one thing is you can identify ATTs at different doses in the same way that we've always done. So if you want the ATT of like $15 minimum wage, you can get it. If you want the ATT of $10 minimum wage, you can get it.
Right.
So I think that's fine. I think there's probably still a paper there. I think the tricky part though is if you want to compare the 15 to the 10 and call differences in effects on employment, causal effects, I think that's the one to be careful. And I think that like, I mean, I think that there's a lot of work to be done. I mean, it might depend on the specific application, but I think at least sort of like grappling with like the nuance of calling those differences in treatment effect parameters and calling those causal effects, I think is something that people should probably do. I think it also sort of like suggests another like weakness of two-way fixed effects regressions, because I think two-way fixed effects regressions are at the end of the day, they're delivering something that's a derivative sort of parameter that includes all of these things from the beginning.
Right.
Alternatively, you could get ATTs directly from each dose.
Yeah.
Now, this wouldn't be kind of like standard operating procedure for most applied economists. You might might have to do some kind of like non-parametric regression on the dose, or if it's discrete, you might have to like get ATTs at each different discrete dose.
Is that feasible? You think that almost sounds like that's going to be hard to do. Like you wouldn't have a lot of units at.
Yeah. So, I mean, state minimum wage is probably a big ask.
Yeah.
Advil, something like that is probably not a big ask.
Schooling, these things might work for that.
Schooling is probably
it's going to depend on the data and the, yeah. Like one thing I was thinking about was this idea that, if you're randomly assigning dosages, right, then there's one average causal response function, if I understand it right, because there's no sorting. So everybody's kind of got like it's almost like, the treatment is independent of the underlying ATT. And so it should be that they balance out. And so then I started thinking, well, you can't know that, right, with observational data, and that's rarely going to happen. But I wondered to myself, randomization kind of some of the things that economists are always doing is like trying to come up with these second best tests, various kinds of placebos, or McCrary density tests, where they're just trying to kind of get at, well, I can't prove parallel trends, but I'll look at the event study, and these kinds of things. So I kind of was wondering what you thought about this, which is like, well, one of the implications of randomized treatment isn't just that the ATTs are identical for these two groups, it's that the covariates are identical, And so I started wondering to myself, well, what if you saw a paper that was like, I can't prove that the ATTs are the same across these dosages, but I am going to look at the covariates across these dosages. And then you're kind of like, yeah, like it's almost like we're back in the world of these the world of the second best econometric stuff, where you're like, can I just like, because then you're sort of saying that the covariates are pretty similar, maybe the unobserved covariates are pretty similar, right? And it's like, this is just classic in causal inference, it's like to do these kinds of things. But I was kind of curious, like, what's your reaction to that? Because you're an econometrician, you're in the business of building solutions, but a lot of applied people are in the business of just like jimmying, kind of like fixing the doorknob kind of with like tape and stuff, And so what's your reaction to something like that? Is that even in principle getting at the heart of the issue, or not really?
I'm actually not sure. So I get this question a lot, and Bacon knows a lot about this. I mean, I think there's something there. Let me kind of punt on that question and talk about one that I know more about. Is like, I always have the idea of like in an event study that you can look back in pre-treatment time periods and try to validate assumptions that way. Like you see parallel trends is validated in pre-treatment time periods, and you get worried, So in that case, I don't think there's an out for what we're doing using pre-treatment periods. So like, I mean, these things, so like
because some in the paper because the bias are these causal parameters.
Yeah, so like we talk in the paper some about what we call strong parallel trends, which is like a version of ruling out these kind of selection bias terms.
Yeah.
But if you make this assumption, I think is close to ruling out selection into the amount of dose, maybe slightly technically weaker, but in the same ballpark.
Yeah.
But if you're willing to make that assumption, you still get the same estimand for treatment effect parameters. You just have made a different assumption and are now calling it ATE, like a global average treatment effect instead of a local ATT. But the estimand is still the same. So like the number would still be the same. If you look back in pre-treatment time periods, the evidence for or against regular parallel trends or strong parallel trends, it would be exactly the same.
Yeah.
And so it doesn't really give you an out there.
Yeah.
I think about covariates, there may be things you can do there. I mean, I think that there are like if the amount of the dose is randomly assigned, I think that does have implications for the distribution of the of the covariates.
It's just, I'm thinking to myself, like, parallel trends, it's kind of like, it's not a surprise the event study came about, right? Because it's kind of like, even though it's not, neither necessary nor sufficient for parallel trends, it's like, look, it's all I can do, right? Like,
Yeah, I mean,
cut me some slack. But
the
this
killer
this has
feature
nothing
on
to do with parallel trends. This bias has nothing to do with parallel trends.
Yeah.
So whatever the future holds for getting at this, it won't be another version of the event study, because that's only really the auxiliary test for the parallel trends assumption, and that's not the problem.
Yeah, that's right.
Right. So
this is a world where parallel trends holds, and then there are other problems after.
So it seems like the auxiliary thing is about comparing the groups. I mean, it's about the differences in the ATT. You can correct me if I got this wrong, but like, it's about comparing the ATTs at a dose for different dosers, right?
Yeah.
At a point in time.
Yeah.
Right. So therefore, if we're going to be doing one of these, like these typical applied innovations, that's like been, almost like the hallmark of what happens when the applied people get a hold of these things and they kind of come up with creative things, it's going to be something like that. It's going to be something like where you're saying, yeah, these are comparable. These are similar. These are comparable. And in the tradition of applied work, that's the placebo.
Yeah.
Right. That's the placebo. And I just wondered to myself, maybe if I'm writing because I'm trying to think, what the heck am I going to say? What am I going to say when I'm refereeing a paper? I mean, it just feels unfair to say, this question is unanswerable, like, I mean, it seems like it's more like, but at the same time, we're talking about program evaluation. We're talking about policy recommendation. You think about it like running a firm. Right. And a firm is like, should I raise price? Okay. And let's say they only can do diff and diffs for some reason. They're like, should we raise price? And they're like, well, we got these situations where we raise price here and we did it different here. And so let's do diff and diff and we'll get it. And if the price elasticity is inelastic, then we can raise price. And if it's elastic, we got a lower price. Right. And it's like, you get it wrong and you hurt the firm. You even get the sign wrong, or not the sign, but you get the magnitude around one wrong and you've hurt the firm. So it's like, I just keep thinking to myself, what's the responsible thing to do now in light of your paper? I mean, what should we be doing? What do you want an applied person to come away from in this paper?
Well, I don't know. I mean, I don't know, Scott. I think they're like kind of philosophical issues about like what can we learn from data. I mean, I think that like I mean, one of the things like when I talk to students here, I mean, I think about like there may be questions that we want to ask that we just can't get the answer to.
Right.
And even more subtly than that, there may be questions that we want to ask where we're really confident about what the answer is. There may be other questions that are kind of in the middle where like we have an answer, but the answer is maybe not as compelling as some other answer.
Yeah.
And I think that's, I mean, I don't know that this is set in stone. I mean, maybe people will have other ideas about how to figure out and address this stuff, or maybe we will have better ideas eventually. But my sense at the moment, at least what we've written, is that some of these questions about comparing treatment effects at different doses kind of sit in this middle ground sort of category that like if you're very convinced about the traditional parallel trends assumption that probably most people have said that they were making, then like that recovers some ATT type parameters.
Yeah.
And all that's the same as before. But if you want to compare them to each other, that you have to bite off extra sort of assumptions.
Mm-hmm.
And almost immediately, as soon as you say bite off extra assumptions, that means that like that those whatever claims are going to be based off of that are going to be at least potentially somewhat less credible than your claims about what the ATT is itself at different amounts of the dose.
Yeah.
Um,
Yeah. 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 I love this paper, man. I mean, I think it's like, I taught it last week at this workshop, and I was like, hey, to me, here's the good news is we're all in the same boat. So nobody has to, when we're all in the same boat, I kind of feel like we can all take some chances and try to think about our own solutions and just let the market kind of pick, like what seems to be promising and what doesn't seem to be promising, in terms of dealing with it. And, I know that, like, that's the thing, is that everybody has different talents, and somebody sees that bias term and they come up with a solution. They come up with some unforeseen solution that they're like, and then other people see the bias term and they're like, their solution's no good. And I just have confidence that solvable problems will be solved with enough smart people kind of looking at it. I think like the market for good ideas is kind of efficient, and, like this stuff gets resolved. And so, I'm looking forward to it. But the thing that I was impressed with is I actually think this paper is almost like it's a really big paper. It's a really big paper because it really is general. It's a general problem. And so this is where I want to kind of end. What actually is not diff and diff once we're working in a world of continuous treatments? I'm almost in a world back in my panel econometrics class, where we were always estimating effects with multi-value treatments. And I'm just wondering to myself, what is a diff and diff? Like, how is it so different? How is it really so different from any panel method? Is it really just coming down to some assumption I'm making? Because, I mean, you said it's got to go from 0 to the continuous level, right? But is that really true? Like, I couldn't start off with because there is no like 0 minimum wage. It's $9 to $10. It's 11 to 15. Everybody's got some starting point of a continuous minimum wage. So are we back? I mean, is diff and diff really so different with continuous treatments than a lot of these panel models that we're learning? Or am I overthinking it?
I think it's different. I think that like kind of a main attraction of like the new stuff that's in the difference and differences world, I think is kind of I don't want to be too opinionated, but like kind of I think kind of being more explicit about like what the target parameters are, being more explicit about the assumptions that lead to those target parameters, and being more explicit about like the minimal set of assumptions that can get you there.
Yeah.
I think I mean this is like it's sort of fascinating that like people have been doing like if you're in a binary treatment world, that people have been doing two-way fixed effects regressions to estimate to implement difference and differences identification strategies for 20 years. And then you have these papers like the Chase Martin Dehofier, Andrew Goodman Bacon's paper that are like, they're super intuitive. I mean, sometimes it's like hard to get to the bottom, but like if you talk to these guys in like not a fancy version of their paper, they can explain all this stuff to you. And it's very clear how this sort of stuff could go wrong.
Right.
Like when me and Pedro were working on this at first, like, I mean, once you're out of the regression world, the solutions are super easy to see. And I think that they're kind of like masked by like mixing together identification and estimation. I mean, I think regressions can be like they're nice paper, like there are these new imputation estimator papers that are nice. Jeff Wooldridge has a nice paper about basically doing difference and differences without the bad side effects of traditional two-way fixed effects regression. but using regressions themselves to implement all this stuff.
Yeah.
I mean, I think regressions are certainly like the leading sort of tool to estimate conditional expectations
Yeah.
for economists, and I think they will be going forward. But I think I think sometimes we mix these things together about like the estimation step and the identification step,
Yeah.
and I think the kind of newer stuff on difference and differences is doing all those things a lot more clearly.
Yeah.
And so I mean, you can. I mean, of course, they're nice papers. Peter Hull has a nice paper about moving into and out of the treatment.
Yeah.
Chase Martin Dehofier, they have another paper about where you can move into and out of a treatment
Yeah.
and difference and differences setup.
Right.
And I think you can do those, and those do kind of like start to have the same abilities as traditional panel data regressions to accommodate complicated treatment regimes.
Yeah.
But then again, the new papers are clear about like what the assumptions are
Right.
that lead to identification there. Whereas I think it's a lot, in my view, I think a lot of times if you just start with the regression,
Yeah.
it's harder to see like what's driving what and what's
Yeah.
important and what's not important.
Yeah. Seems like you have to discipline the regression because he's like the hungry hippo. He loves variation, so he's going to find every conceivable way to find any variation in the data, including comparisons with the old world. And so so you just gotta strap him in, which it seems like Jeff Wooldridge just kind of figured out the specifications to kind of strap him in. But my feeling is always like, well, I mean, I can also do it another way, which is I could use Callaway Santana, or I could use Borsuk et al. And do it too. And I guess you're starting to trade off like properties, like, which parallel trends assumption do you want? And like, I don't know. I actually don't quite know how to articulate. I mean, I really don't know yet how to advise, do this one instead of this one. These things are starting to get really deep. And I think a lot of people are like learning one, but don't really know how to walk around,
Well, so I mean, my sense, Scott, is like that all of these kind of like modern differences, like in binary treatment world, I think they're at heart almost the same sort of idea. I mean, they're all you want to make the good comparisons that show up in the two-way fixed effects regression. You want to forget the bad ones.
Right.
Figure out some way to do that.
Yeah.
And all of them have the flavor of like some kind of like two-step estimation procedure where you estimate something disaggregated at the beginning.
Right.
We can call these, like in mine and Pedro's paper, we call these group time average treatment effects. You can, if you want to do imputation stuff, I mean, to me, imputation is not really all that much different. I mean, it's just like a further sort of disaggregation, but still you estimate something that only involves untreated potential outcomes in the first step.
Right.
And then put them back together in a second step. Jeff's paper's like that too. I mean, it's not like I always have the idea that like the reason why two-way fixed effects regressions took off so much was that if you read the textbook version of this where there are two time periods, you can just run this really simple regression.
Yeah.
You can get a numerically identical estimate.
Right.
You can get standard errors.
Yeah.
You can calculate the averages, but you have to figure out the standard errers.
Exactly.
A little bit harder to do, and so people just did the regression.
Exactly.
But like even like I think I don't want to misspeak here, but I think Jeff's paper, you still have to do some kind of two-step sort of regression. You run one regression and then you run a second regression. So I think all of these kind of have the same sort of like basically two-step flavor of like make good comparisons somehow, and then combine them back into a smaller number of parameters. I mean, it edges some things are so like if you're I don't know, like some of this stuff about like if you want to assume parallel trends over all time periods, you can get more efficient estimators. If you do imputation stuff. If you want to
Mhm.
make fewer parallel trends assumptions, you can do the stuff that Pedro and I propose. But my sense is that those things are all along the edges. So like, I
Yeah.
mean, you could do a version of like what Pedro and I do, where you use parallel trends across all pre-treatment time periods
Yeah.
and increase the estimation precision. If you want to do imputation, you could chop off a bunch of stuff at the front
Yeah.
and get more rely on fewer parallel trends assumptions. So I
Yeah.
don't think that they're like fundamentally different along those regards.
Yeah.
I think they're. I mean, they are different, but I think the underlying ideas are all very similar.
Yeah.
And I think any of them. I think you take any of them off the shelf. I think they just are way better than
Yeah.
the traditional two-way fixed effects regression.
Yeah. Yeah. Prime people loose of two-way fixed effects. I mean, we love it. Yeah. We love least squares, and we love, I mean, it's like, it's a challenge. So, okay, let me conclude with this. You're looking forward. All right. And, you close your eyes and you float into space, and then you like sit up there and you come back down, and it's 5 years later. What do you see different in the applied community when it comes to these diff and diffs? What do you think they're doing that we're not, that's different than right now? If you had to make a prediction, where is it going?
These are hard questions. These are things
Yeah.
I've never thought about before. Yeah, I don't know. I mean, I hope that people will be that it'll be standard practice to use some kind of modern, recently proposed difference in differences estimation strategy. Besides that, I don't know. I mean, I mean, I don't think that if you have more complicated treatment regimes, I don't know what's going to happen there. But I do think, I mean, if you take as a baseline kind of the traditional two-way fixed effects regressions, I think there are going to be real improvements there. I don't know that those will be solved problems in 5 years, but I think people will have a good idea about like what the important conceptual issues are, and will at a minimum have better, if not perfect, estimation strategies. I think along a different vein, I think there's a lot of like interesting things to think about regarding like I like this stuff about like conditional parallel trends. Like you believe parallel trends holds after you condition on some covariates. I think there's a lot of interesting things to think about there.
Yeah.
Potentially, there's a little bit of work on like machine learning sort of stuff.
Yeah.
There, I'm interested in. I kind of grew up on like these beautiful results about like non-parametric. Like you want to estimate a treatment effect, you have a bunch of things you want to control for. You can control for them in a non-parametric sort of way. And there were these beautiful theoretical results about that I learned that we would learn in class, and then you'd sit down at the computer and it just wouldn't work all that well.
Right.
I think, at least for me, I think machine learning holds out the possibility of the beautiful results actually working in practice.
Yeah.
I guess like non-parametric methods, maybe you can say better than I do, but I know a lot of applied people have a distaste for the sorts of like tuning parameters that researcher degrees of freedom that show up there.
Yeah.
I think it'll be interesting what plays out there.
Yeah.
What do you think will happen with that?
I think this diff and diff literature is I mean, diff and diff is the modal paper we write, design wise, most of us, in the applied community, my generation, right? Like, it's not the only thing we do all kinds of stuff, but it seems like if we're going to repeat ourselves, it's a diff and diff, because it's the easiest to do with like, state federalism. Everybody's picking all this stuff. Right. And so, it's like, we just live in this laboratory, or at least we kind of feel like we do.
Yeah.
And so, I think that, Andrew in Bacon's paper, just to take one, I think for some reason, Andrew's paper hit a real nerve, even though there were other people like, Borsak and Yarville and the Chase Martin and Hopeful and others. Andrews kind of freaked people out because it was such a pessimistic paper. It was kind of like no solution, and it just spread through the community. The fact that it spread through the community the way that it did, I think suggests something, which is our most important tools are broken, or it made people felt that way, and so what I think is a couple of things. One is, one of the things that I've noticed about diff and diff historically, is it was seen, two-way fixed effects was seen as the transparent, transparent, least black boxy method. Like if you compared it to synthetic control, you'd be like, synthetic control is mysterious. I don't get it. Diff and diff is simple. And I think there's a couple of things that have come out of this, which is two-way fixed effects is apparently was always the black box more than we thought. It was doing stuff we didn't know it was doing. And then secondly is this issue of weights. I never heard about weights ever, right? Now I hear about weights every day, And so it's well, that's what synthetic control is weights, I hear about imputation now, right? And, and that's what synthetic control is. And so I keep thinking, I wonder if all y'all's papers have kind of made people, it's almost like the relative price of the relative price of more structural approaches fell because two-way fixed effects actually wasn't what we thought it was, and so it's forcing people to go back to the books and to learn all these other things, and they're not agreeing on what to do. One paper does Callaway Santana, another paper does Son and Abraham, another paper does Borsak Yarvel, another paper it's another paper does stacking. So I think all of that disequilibrium is interesting. And I think what it's going to do is make people a little more open-minded to stuff that has not been in the toolkit, like structural approaches, maybe, I don't know. So that's one thing I think is I think these papers have probably done some kind of dislodging, and we're not in equilibrium. And who knows what the equilibrium is? I mean, the equilibrium should be, that the typical applied person has a much deeper level of, knowledge of the experiment that they're studying, such that they go, yeah, this is the parallel trends I want, and this is the parameter that I'm after, and so I'm going to choose this one because I have a good reason. As opposed,
when you say choose this one, what do you mean?
They choose Callaway Santana over this, two-stage diff and diff, or the robust imputation estimator, or whatever.
Do you ever see papers that implement multiple ones of these? Do they ever lead to much different results?
Well, I have for my students. This semester we replicated Ching and Hoekstra, the Castle Doctrine paper, using Callaway Santana, two-way fixed effects, Callaway Santana, Borsak et al., and matrix completion with nuclear norm regularization, and the results were pretty simple. And it was it's why were they, and stacking, and I was so why are they similar? And that was kind of interesting. It was why are they similar? All this stuff's, the engines are different, the assumptions aren't always the same. The techniques are a little bit different. And so I thought that was kind of interesting. And it made me think, I wonder in practice, what is mattering, but no, I don't see, what I actually see more is well, this is the one I know.
Yeah.
I sat down and studied Callaway Santana, so I'm going to do Callaway Santana because everybody's got diff and diff fatigue.
Yeah.
They're just tired.
So my thought is that so matrix completion is different. I don't think that there's really in fact, it could be much different than other approaches. I think in principle it's possible to get different sorts of answers with different of these sort of like new strategies. But my sense is that that should be rare. As far as I know, maybe up to like some small implementation details, but I think at least the simple versions, like where you don't have covariates or something of imputation and like Wooldridge's like two-way fixed effects, I think they give you exactly the same answer.
Yeah.
I think Abraham and Son and Abraham, I think basically they include more dummy variables. So like the identification is off of like more local comparisons, but it's very, very similar sort of in spirit.
Yeah.
And our stuff, I mean, actually, I think I may be speaking, I'll say this with like 90% confidence, but like, if you think about like all of these, I think should give you very similar answers up to like functional form assumptions about covariates, up to like how far in the past you invoke parallel trends assumptions.
Yeah.
I think if you download these, I think what's going to happen, say you do Borisek and Jervel and Spieth's paper, I think if you download their code, it's going to use all the data that you have in all the time periods.
Yeah.
And so that's going to tend to give you efficient estimators, but tend to require stronger assumptions.
Right.
If you took, say, our stuff or Son and Abraham stuff, it's going to tend to, it's not going to use deep pre-treatment time periods.
Yeah.
And so it's going to tend to give you less efficient estimators, but robust to violations of parallel trends in pre-treatment time periods.
Right.
So I think that's what's going to happen if you download the code. But I don't think conceptually that they're all that different. Like I think you could do a version of imputation that was.
I mean, that was reassuring when I did Ching and Hoekstra. You know, or I have a simulation I use a lot, and I did it on the simulation. You know, what like the simulation has complete staggered rollout, and then Ching and Hoekstra has like, you know, about 30 never treated units. And, you know, and you see this also in Kirill Borsuk has this nice simulation, and it's like, yeah, like the confidence intervals seem to be different, but like, I mean, maybe I'm just kind of like a pedestrian guy, but I'm like, they don't seem too different, you know, like this isn't huge, you know, like, and so I definitely feel like, you know, they're pretty similar. If they're not similar is when I think, you know, something's going on.
Well, I mean,
and that's where there could be p hacking, you know, because a person says, well, I'm going to use this one because this one's giving me these nice event study plots, you know?
Yeah.
And then you don't really know what the heck's going on because it's not showing up for all of them.
I mean, I think up to like, so in a world where you have covariates, it would perhaps be a little bit different. But in a world where you're doing differences with no covariates, like I think the only different, like if you get different results, if you get if you get wildly different results, then I think it would suggest that you should do the Callaway and Santana, Son and Abraham. Because I think they're going to work under certain violations of long parallel trends across all.
Because it doesn't have that.
So I think that would be
fixed effects model or something.
Yeah, I think that would be I think that's the only source of systematic differences that could lead to big differences. But I think like the plot you showed, that if you're getting like similar estimates across different methods, I think the standard errors are likely to be smaller
under Borisov.
But again, like, I mean, my sense is that like it's sort of like just a code availability issue because I think if you're like I've already written my paper, it's imputation. I don't want to totally switch, but I'm worried about like that there are violations of parallel trends in 20 periods before anybody becomes treated. You can do a version of imputation that doesn't rely on that. And it's going to lead to less bias, but also less efficient estimators than the ones before. So, I mean, I don't I think mostly those differences are practical differences about the ways that different authors have chose to implement their strategies,
Yeah.
rather than being fundamental differences
Yeah.
across approaches.
Yeah. I just wonder if the diff and diff literature, and especially this like focus on the weights. I just can't get it out of my mind that this like the saliency of this, like, everything is a weight, is an aggregated parameter. Like these, you're getting these weighted averages, and you never heard that before. You never heard that before. Or if you did, it wasn't like, it was like a uniform weight, or it just wasn't something that you would hear a lot about, because
maybe you're like a Josh Anger student or something.
Yeah, probably. Right. I mean, yeah, like, yeah, that didn't count. It's like the mere mortals that went to normal schools, didn't hear all this. But like, I just wonder in my mind, I'm like, I wonder if there's going to be an open-mindedness to more tools, because diff and diff turned out to be more complicated than we thought, or two-way fixed effects, or diff and diff. Yeah, diff and diff was more complicated and required these like delicate solutions. But even though they're real intuitive, they still required, like unlearning some stuff and then relearning some stuff. And it just makes me think, who knows what we're going to be doing? Maybe we're going to be more open to these machine learning based causal inference modeling, or because like, now you're kind of realizing like, oh, I gotta make some assumptions, like you were always making assumptions, but so a lot of people didn't think you were. A lot of people were just like, no, I'm not making any assumptions. If the pre-trends hold, that's it. I just tested it. And it's like everything was really easy for a while. And I just wonder if, maybe it's like maybe it'll be a nice little flowering of like, of econometrics in general, just, being thinking about let's stuff our toolbox with more tools and not just like one tool.
Scott, what about, so what's, people ask me this question a lot, and I have kind of a stock answer, but it's probably one you know a lot more about than I do, is what's your sense about like how much, like if you switch to Callaway and Santana, say, from two-way fixed effects, how much of a difference does it make in a typical application?
In Ching and Hoekstra, it doesn't really matter. And the thing is, like, the thing is, though, when you do Ching and Hoekstra and you do that bacon decomposition, which I don't think you should over rely on that, but when you look at it, like the majority of the weights, like 0.92, are on the good stuff.
Yeah.
And so it's like, I keep thinking to myself, I keep thinking, I wish I knew the math of it, but I keep thinking like, it's when you have that large reservoir pool of never treated units, like, and, or, so if you've got that and if you've got that and you've imposed on the model or on the coefficients is that, weights sum to 1, then it's almost like it just crowds out the amount of weight that it could even put on those already treated units, because it's like, there's no room left. So it's like, that's what it seems like, is the deal. And so I kind of keep thinking like, Clemens and Strain have this new minimum wage paper where they're looking at the minimum wage increases after the Great Recession, where they were pretty big. Like Singh et al. Has this QJE and they like find no effect. And, over a 30-year period or whatever. And then Strain and, Clemens and Strain do it. And they're like, well, these minimum wages are kind of big. And so they do two-way fixed effects and they find this thing, and their event study plots don't look great. But I mean, at the same time, it's like, they don't look horrible. They're not like some of the stuff that I've done where it looks like a 5-year-old made it. It's like, I mean, and so then they do stacking, and then they do imputation, and it's like the same number. And I just keep thinking to myself, I wonder when the dust settles, if we're going to be like, yeah, these dynamic treatment effects are a big deal, but maybe markets adjust really quick and the dynamic treatment effects dissipate really fast, or like, or we've got such a large body of untreated units that it's not like we can't even we're not even in the world where the bad forbidden comparisons are happening too much. So it's like, I do wonder sometimes if I've overscared people in my classes, because there's value in scaring people. It's like you tell kids stories about boogeymen so that they won't, go outside. Right. But, most kids, if they go outside, nothing's going to happen.
Yeah.
And I keep thinking to myself, I wonder if for all this robust diff and diff stuff, and yeah, you should do it, because the part of the stuff with the robust diff and diff stuff, and you've kind of said this a few times, and this is something that I don't think a lot of applied micro people are really hearing. A lot of what I think econometricians are offering isn't just the tools, it's the it's the insistence. Define your target parameter. What exactly are you identifying? What is it you want? What is it you want? You want the ATT? Good. Then let's do something that gets it, right? As opposed to letting the model tell you what parameter you've identified and it's a weird one, right?
Yeah, I totally agree.
And so I sometimes think one of the lessons of all this robust diff and diff stuff is just to slow everybody down and just be like, hey, let's just start over for a second. Like, what is your question? Why, what is it? Are you after that? Well, if you're after that, some stuff gets you there and some stuff doesn't, and, thankfully it's 2022 almost. And, it's all figured out, except for with continuous.
Well, yeah. I mean, econometricians, we can keep making things more complicated indefinitely.
Right.
But I do think, to your point, some of the things about two-way fixed effects regressions, I think I sort of have the same idea too, that we're not going to vastly we're not going to go from thinking the minimum wage had no effect or maybe a small effect on employment to all of a sudden you do this and now we realize that it had a huge negative effect on employment. But I think it does sort of stop us from doing the I think there at least used to exist papers where everyone became treated and you estimated an event study way out 20 periods into the future where there's and I think that stuff has probably gone away in the last.
Yeah. I think so.
People have realized that there's no identification.
Right.
I mostly agree with you. I don't think that the world is going to be overturned by doing kind of modern difference of differences stuff.
Yeah.
But I also think that I do think it's better, and I do think it it's not a big ask to switch the method. And I think you just rule out from the beginning. It's always kind of my sense is that or at least what I hope will not happen is that standard procedure will be do two-way fixed effects and do Bacon decomposition and try to see if it works.
Yeah.
I think you should just take something that works. I don't think that there's any reason to go to all the do something that may not work.
Yeah.
See if it works. Just there are tons of easy things that you can just take off the shelf and do them, and you won't run into any of these issues.
Yeah.
And I think the costs are very low to.
Yeah. Well, I mean, now that all the codes in Stata, I mean, that I really think at the end of the day, if you can get it in Stata, then you've won hearts and minds. It's you leave it in R, and a bunch of old people like me are I'm going to have to hire somebody on Upwork to do this because I don't even know how to do it. I don't even know how to turn R on. But hey, man, it's been really nice chatting with you. And I think
sorry I'm so long-winded.
No, this was fun. This was a lot of fun. I hope people enjoy, this kind of back and forth. I mean, I think that that you are just doing such great work. I mean, I think like, I'm not an econometrician, so I can't speak to what the econometricians think, but I know that I think it's just really beloved work by a lot of applied people, and a lot of applied people are just really grateful that that about the work that you're doing, and it's exciting to see your career kind of continue to go. And this continuous paper, I think, is, even though it's bad news, like, I don't know, the truth is always good news, and so like the bad news is doing stuff and not, and like the bad news is being wrong. Good news, good news is knowing, knowing what the heck you're doing. And I think that this continuous paper is really, really helpful, even if it doesn't offer us a lot of solutions. I think I'm just confident that people are they're gonna find the way around it. Finding better comparison units. That in some ways, I wonder if that's not the solution, which is like, we need, it's almost like the continuous paper just reminds me a little bit that like, more data is not better. Sometimes maybe finding proper comparisons is really what we're doing in causal inference, not just, mindlessly dumping the data set with a bunch of units.
It'll be interesting too if they're like kind of like application specific sort of solutions.
Yeah,
I mean,
exactly.
I think that like all of that stuff is like, I mean, it's hard. Yeah, I think there are potentially possibilities of like different sorts of strategies that to address these sort of issues that make more or less sense in different applications. And
yeah. Okay, cool, man. All right.
Thanks, Cap.
Well, it's good to talk to you.
Yeah,
all right.
Thanks a lot.
Bye-bye.
This has been fun.